This is an installation of one large centrifugal air compressor, and you can see cooling water supply and return header have been installed in front of coolers. Due to the cooling water headers, cooler bundle cannot be removed directly. It will foul with the pipes. But several Victaulic couplings have been provided on the pipeline so that pipeline can be dismantled during cooler bundle removal using these Victaulic couplings. Now let us see the purpose and design philosophy of these Victaulic couplings. Suppose this is one compressor aftercooler or intercooler, and this is one cooling water line in front of the intercooler or aftercooler. So cooler bundle removal space is like this. When this cooler bundle will be removed, then this cooler bundle will foul with this pipeline. So one option is we provide one flange joint here like this, and another brake flange joint here like this. This is one option, so that during cooler bundle removal, this flange joint and this flange joint will be removed, and this pipe spool will be removed, and cooler bundle can be removed. But this flange joint involves two flanges. This flange joint involves two flange joints, welding and bolting. So this flange joint will be costly. There is involvement of welding, there is involvement of bolting and gasket. So this dismantling time will be more, and again mounting time will be more. Another option is we cut the line in front of the cooler and provide groove on the pipe like this. On each piece, this side one groove, and this side one groove, and on the adjacent pipe piece, this side one groove and this side one groove. In this groove, one coupling is provided like this. This coupling is in two parts and bolted, and after bolting, this coupling is pressed over the groove. This coupling is called Victaulic coupling. When we want to remove the cooler bundle, then we dismantle this piece of pipe by removing this Victaulic coupling joint and this Victaulic coupling joint. Then again we can mount this pipe using the Victaulic coupling quickly by bolting. Now let us see how this Victaulic coupling works. Now suppose this is the pipeline in front of the cooler. To provide Victaulic coupling, this pipe piece is cut here with 1 millimeter gap, and here also with 1 millimeter gap. So this is one pipe piece, this is one pipe piece, and this is another pipe piece. And In this pipe piece, after 20 millimeter, 10 millimeter wide groove is provided all around the periphery of the pipeline. This groove depth is 3 millimeter, and this side also same thing. This is the groove 10 millimeter wide, and this distance, that means from edge of pipe, is 20 millimeter, and groove depth is 3 millimeter, this depth. In these two grooves, this Victaulic coupling is provided, one in this side and another is this side, and then it is bolted. Now in this pipe joint, first this green one is the 3 mm thick neoprene or EPDM rubber sleeve is provided first. Then this is the Victaulic coupling. This portion is having width of 8 millimeter. So this is top part and this is bottom part. After bolting, this 8 millimeter portion will sit over this 10 millimeter groove. This also. Then after bolting, this Victaulic coupling will press this rubber band or rubber sleeve and will sit over this groove. This same set of Victaulic coupling is provided here also. So when we want to remove this pipe piece, we want to remove this Victaulic coupling and this Victaulic coupling. Now you can see the bolting between upper part and lower part of Victaulic coupling. Since the depth of the Victaulic groove is 3 millimeter, while calculating pipe thickness, this 3 millimeter groove should be considered. Now, at the location of Victaulic coupling, the pipe is not continuous here and here. So, axial pressure thrust will work in this direction and in this direction, here also in this direction and in this direction. And quantum of axial pressure thrust will be cross-sectional area of pipe into internal pressure. Say this is 16-inch pipe. So OD is 406 millimeter. Say thickness is 10 millimeter. So ID is 386 millimeter. And say internal pressure is 10 bar gauge or 10 kg per centimeter square gauge. So axial pressure thrust will be pi d square by 4 into 10 equals to 11,696 kg. So 11,696 kg will act in this direction and will act in this direction. This is called axial pressure thrust. Now we have to check whether this Victaulic coupling joint is well enough strengthy to resist this axial pressure thrust. Now we have to check two checkpoints to resist the axial pressure thrust. One checkpoint is shearing of pipe or clamp and another checkpoint is bearing of clamp. Now the shearing area of pipe is this much, width of 20 millimeter, but shearing area of the clamp is only 8 millimeter. So we should check shearing area of the clamp. So shearing area of clamp is circumference of the clamp into clamp width. So pi into 40.6, that means OD of pipe, into 8 millimeter, that means 0.8 centimeter, equals to 102 centimeter square. So shear strength is 102 into 80% of allowable stress in tension. For carbon steel pipe and clamp, allowable stress in tension is 1400 kg per centimeter square as per ASME 31.3, and allowable shear stress is 80% of tensile strength. So shearing strength of clamp is area into this allowable shear stress equals to 114240 kg. So shearing strength of the clamp is much more than the pressure thrust. So from shearing point of view, the clamp is okay. Now bearing area of the clamp. Bearing area of the clamp means this area. So this outside area is pi into d square by 4. That means 40.6 square by 4. And since the groove depth is 3 millimeter, this side and this side, so this area is 40 square divided by 4. So pi into 40.6 square divided by 4 minus 40 square divided by 4 equals to 12.09 centimeter square is the bearing area of the clamp. That means this area. And bearing strength equals to bearing area into 1.6 into 1400. As per ASME 31.3, bearing strength is 160% of tensile strength. So bearing strength is bearing area into 1.6 into 1400 equals to 27082 kg. This 27082 kg is also more than this axial pressure thrust. That means this clamp is safe from shearing point of view and bearing point of view. Now, this type of Victaulic coupling is having flexibility also. Since this groove gap is 10 millimeter and this clamp width is 8 millimeter, so in axial direction it can play by 2 millimeter, and in lateral or bending it can also play something like this. So this is having flexibility in lateral and bending also. Similarly, it is having flexibility in rotational or torsional like this. So this Victaulic coupling is having flexibility in axial direction, in lateral direction, as well as in rotational or torsional direction. Now suppose the pipeline diameter is huge or internal pressure is huge, resulting very high axial pressure thrust. In that case, if we see that this coupling joint is failing in shear or in bearing, then what we should do? In that case, we have to provide one gusset plate on this side of the pipe with RF pad and another gusset plate on this side with RF pad, and we will have to provide one bolt like this with nut. This bolt is as like tie rod of a expansion bellow or expansion joint. This bolting will be kept tight, and this side also similar bolting will be there, so that additionally this bolting and gusset plate will take care of this axial pressure thrust. Now you can see this Victaulic coupling having two tie rods at 180 degree apart, and you can see this Victaulic coupling having four tie rods at 90 degree apart.